Have you ever heard of the facade pattern? We'll break it down today. My name is Gene and welcome to Do Some Diff. Here are the topics of this video. We'll begin by laying the groundwork for the facade pattern. Now that we made sure that we understood all the basics, we are ready to create an example in the programming language Java. To strengthen our understanding, we'll create another example in the programming language Python. The facade pattern is one of the so-called structural patterns. This pattern is particularly well suited to address complexity and dependency management. Complex systems, especially those with a large number of classes and functions that work together, can make it cumbersome and error-prone to interact with. Particularly new users, not yet knowing every detail about a system, may have a steep learning curve. This is where the facade pattern brings a lot of value, and once understood, it's fairly easy to apply, as it basically provides an interface to hide the complexity of the underlying system. It exposes a smaller set of methods that are easier to understand and use. Imagine you are hungry and you want to cook something nice to eat. The problem though is that grandma's dish is complicated and hard to reproduce. What did grandma say again? First the onions, then the basil? And what about the tomatoes? When do you add the olive oil? And when do you heat the oven? As you might already understand, this process is terribly complex. And this is where the facade pattern shines, introducing a simplified interface as a single point of interaction. The only thing you will worry about now is telling your friend, the facade, to cook grandma's delicious dish, without you needing to remember all the detailed steps. Now you are happy, because getting good food has become incredibly easy. And your grandmother will also be happy, because you will not have to keep re-asking the same questions all over. Okay, dependency management. The more you interact with your system, the more your code becomes tightly coupled to the specific implementation details. This tight coupling can be difficult to maintain and to test. The advantage of the facade pattern is that it creates a layer of abstraction. This decouples your code from the underlying system, allowing you to make changes to the internal implementation without affecting the code that uses the facade. Let's say your grandmother notices the missing ingredient, oregano. You can tell your friend, the facade, to incorporate it, but it does not change the fact that you have to ask your friend to cook something nice. By addressing these problems, the facade pattern promotes loose coupling, improved maintainability, and easier understanding of complex systems. Real-world examples could be software libraries, hardware interfaces, or fast food restaurant interfaces. Let's quickly take a look at the pattern structure. The first thing that we need are the subsystem classes. Those should consist of functionality that we actually already have. The subsystem classes refer to the individual classes or functionalities that make up the complex system. These classes are hidden behind the facade, meaning that the client code does not interact with them directly. The next thing that we need is the facade itself. The facade class itself is the intermediary that simplifies the access to a complex system. It acts as a single point of interaction for the client code, shielding them from the intricacies of the underlying system. Alright, now we're ready to take a look at the Java code. The first thing that we build is the subsystem class 1. This class has a method, operation1, which does not return anything, hence void. The only thing that we do here is printing a text to the terminal. Subsystem class 1 calls operation1. The next thing we need is the subsystem class 2. Here we implement the method operation2, returning nothing, hence void. The only thing that this method does is printing a text to the terminal. Subsystem class 2 calls operation2. The next thing we build is the facade class. Here we start by declaring the two subsystem classes privately. To ensure that we have subsystem classes to access, we provide values for them using the constructor. Now we build up a new method, subsystem operation, which does not return anything, hence void. What this method does is handling the complex process of execution. In this example, it first executes operation 1 and then operation 2. Now we build up a main class, starting with the main method and a greeting message. Now we create instances of subsystem class 1 and subsystem class 2 and another instance of the facade class. Now we are ready to execute the subsystem operation. What we now need in this Java application is the manifest.txt, which tells Java that our main class is main, and then we need one build script for building the application under Windows, another one for Mac and Linux, and a run script to execute the application under Windows, and another one for Mac and Linux. Now let's build and run the application. And let's take the main class as a reference for the terminal output. And here we can clearly see that the subsystem operation of the facade has executed the subsystem class 1 and the subsystem class 2. Alright, now let's take a look at the same thing in Python. The first thing that we build is the subsystem class 1. Here we define a method operation 1, which does none other than printing a text to the terminal. Subsystem class 1 calls operation 1. Now we build a second class, subsystem class 2, in which we define a method operation 2, which also does none other than printing a text to the terminal. Subsystem class 2 calls operation 2. Now we build the facade, starting by importing the subsystem classes, and then defining an init method to take the values for the subsystem classes. And then we define a method, subsystem operation, in which we execute the operation 1 and the operation 2. Now we build out the main method. Here we start by importing the subsystem classes and the facade, and then we define the main method. The first thing we do here is creating a greeting message, and then we create instances for the subsystem classes, and then we create another instance of the facade class, and then we execute the facade's subsystem operation method. Last but not least, we tell Python to execute the main method. Now we build a run file for executing this application under Windows, another one for Mac and Linux, and that's it. Let's run the application, and let's take the main method as a reference. And here we can clearly see that the subsystem operation of the facade has executed the subsystem classes 1 and 2. Alright, we have explored the facade pattern in both Java and Python. What are your experiences? Is this totally new, or have you already worked with this pattern? What's your biggest takeaway from this video? Share your thoughts below in the comment section. Are you ready to code this yourself? You can find full walkthroughs and downloadable code on my website and on GitHub. Check the links in the description of this video. I'm glad you're here to dive into topics like this visually. Ask me anything that pops into your head, and let's brainstorm some ideas for future explorations together. Alright, we're through with the facade pattern. I'm happy, you are happy, and grandmother is also happy. See you in the next video.